In experiment A4, we are making use of the ideal gas equation to allow us to calculate the MR of a liquid, in this case hexane, a volatile liquid. Just to start off proceedings, I'm going to take this gas syringe and draw about 5 centimetres of air into the barrel of that syringe and pop the little cap on. So this is a self-sealing cap, which once it's on there, I shouldn't then be able to move the syringe barrel. So I'm just checking that before I do anything else. The next thing I need to do is fill up that really tall beaker with some water, some hot water from the kettle. So I've just freshly boiled this kettle and I'm just going to carefully pop some hot water and get it pretty full so that as much of this gas syringe as possible is immersed in that water. I'm also going to use a thermometer now to just measure the temperature of that water, like so. And whilst that's working, I'm going to go and put the kettle back on in case we need to top it up in a moment. So I'll put the kettle back on here. So the volume of that gas in that syringe has not really changed at all. It's 5 centimetres cubed. So the start volume of gas, 5 centimetres cubed, like so. The next thing that I'd like to do then is to deliver a known mass of hexane into that gas syringe. So the next step is to add some of the hexane, that's a volatile liquid, into the gas syringe. And to do that, I'm going to use a hypodermic syringe. It's got a needle attached so I can inject through that little rubber self-sealing cap. But to be able to do that in a known quantity way, what I'd like to do is measure the mass of the syringe and the needle in the cap with some hexane in it, then deliver some hexane, and then re-record the mass of the syringe and the remaining hexane with all of this stuff still attached. I need to work in the fume cupboard for this. I'm going to need, there's not very much in this bottle, so I need to just pour a little bit into a small beaker. Notice how there's no naked flames around. I've got the gloves on because this stuff can irritate the skin as well. So I'm going to work in the fume cupboard. It gets a bit noisy with the fan, so all I'm going to do is go into the fume cupboard, add a bit of hexane to the syringe, make sure it's all sealed and not leaking, and then I can bring that out safely onto the balance. So the total mass then of the syringe and the cap, the needle and the hexane is 6.52 grams. 6.52 grams. And I don't need much of this stuff, so I need about 0.2 mils of this. So again, now I'm going to move back into the fume cupboard and I'm going to take this across. Before I do that, let me just check that that volume has not changed. It hasn't, and the temperature on that thermometer 81 degrees C, so that should be plenty hot enough for what I need to do next. So I'm going to just temporarily take this gas syringe out of the hot water bath like so. It's quite warm, so I need to be careful. I'm going to move everything into the fume cupboard to inject a little bit of hexane, then I'll bring it all back out when that's safe again. in there to vaporise the hexane, that volatile liquid. You might be able to see the barrel of this gas syringe coming out there now as that vaporises. Whilst that's just settling down, I'll pop that onto the balance. 6.17 grams. 6.17 is the final mass. 6.17 grams, plus and minus 0.01 grams. The barrel of the syringe is still moving away. I'm just having a look at the thermometer temperature. The thermometer temperature is now at about 78 degrees C. This barrel of this syringe is moving nicely. I'm hoping that it slows down soon, because I may have injected a little bit too much hexane, in which case I've got to start again. It overshoots, but we shall see. It seems to be slowing down. Just checking that the temperature is still high enough. It's at about 77 at the minute, so that's high enough. That's good. The barrel's still moving very slowly, but it seems to have just settled about there. Give it another moment to just check. Yeah, I think that's stopped moving now. So we're at 86 centimetres cubed at 77 degrees C. 86 centimetres cubed at 77 degrees C. Now, ideally, then what I would do is repeat that measurement several times. So to do that, go back to the fume cupboard with the gas syringe and the barrel, empty it out by flushing it into the fume cupboard with the fans running is the safest way to dispose of that really tiny quantity of the hexane there. Similarly with this, I need to dispose of that carefully into the fume cupboard as well. And just repeat that process and see how close the different values of the MR might be. Before we finish, I might show you what happens though if I take this out of this beaker of hot water, because this is quite interesting. So take it out of the beaker of hot water and just let it cool down a little bit, and the hexane starts to condense, and eventually we get below the boiling point of hexane. I can see some condensing hexane just on the sides of this gas syringe inside there just now, and watch what happens to the barrel of the syringe all of a sudden as the boiling point of hexane is not met. As the temperature reduces down, the volume contracts, absolutely loads, which gives a little bit of evidence that gases have a much greater volume than the associated liquid.